Sign test is a non-parametric test. The primary objective of the sign test is to test the unknown value of the population median. So most of the times, students, the population is unknown to us. So if the assumptions about the normality are not met with any sort of data, so we can find out the unknown value of the population median, and we can, using the sample data, we can estimate it through the sign test. In this module, we will be discussing a real-life problem onto which we will be applying the sign test to find out the unknown value of the population median. The problem here is the endurance scores of animals during a 48-hour session of discrimination responding are recorded. The median scores for animals with electrodes implanted in the hypothalamus were 97.5. Suppose that the experiment was duplicated in another laboratory, except that electrodes were implanted in the forebrain of 12 animals. So the data is given before you. Use the sign test to see whether the investigators may conclude at the 0.05 level of significance that the median endurance score of animals with electrodes implanted in the forebrain is less than 97.5. So students, here our alpha is 0.05 and the population median we need to test. That means our hypothesis is of type less than 97.5. That means we are going to test the hypothesis about the population median which is directional in nature. So let us first talk about the hypothesis procedure for testing this particular type of hypothesis. So students, the first and foremost step is to formulate the null and alternative statement. So the alternative statement about the median was already been given to us. That is, median is less than 97.5. So we are going on the basis of this statement, we are going to construct H naught, that is M equal to 97.5, or you can also write it as M greater than equal to 97.5. So here alpha is 0.05. Now students, as the number of values are 12, so we will be taking the normal distribution to test this type of hypothesis. So the test statistic for this is Z, that is K plus 0.5 minus 0.5 into N divided by 0.5 into under root N. So this is the large sample statistic we are going to use to test this type of hypothesis. As far as the calculations are concerned, students, the first thing we would have to do is to find out the differences. We are going to subtract the original observations from the median in order to see that how many values are less than the median, how many are equal to median, and how many are greater than the median. So we have calculated this step xi minus 97.5. As you can see that 93.6 is less than 97.5. So whenever we are going to subtract 93.6 from 97.5, so that will give us the negative value. Similarly, for 89.1 value, this observation is also less than that of the median 97.5. So when we would be subtracting this observation from 97.5, again we are getting a negative sign. The next value, students, is 97.7. Now this value is larger than the median. So when we will be subtracting 97.7 from 97.5, that is giving us a positive value. So we are going to count down the negatives and the positive signs in this manner. Now students, here I would like to point out one value, that is 97.5. It is exactly identical to the median. So the answer will be 0. Now in the upcoming steps of the calculation, you will see that as our number of values were 12, but we are going to consider it as 11 because one of the value is exactly equal to the median. So we are not going to take up that value. So plugging all the values in the Z, here this 2 is representing the K. Now what is K, students? K is the number of positive signs in the data. So there were 2 plus 0.5 minus 0.5, and here you can note down that I didn't take n as 12. Why? Because one of the value was equal to the median. So skipping that value, we are just left with 11 number of values. Divided by 0.5 into under root of n, that are the leftover sample values, we got Z as minus 1.81. Now we are supposed to observe this value under the cumulative normal table. So students, if I will be looking this value in the cumulative normal table, the probability I am going to get is the 0.0352. Now we are going to compare this calculated value with the tabulated p-value. So students, as far as the critical region is concerned, we have stated that we will have to reject H0 if p-value is less than alpha. So students, आपने देखा कि हमारी p-value 0.0352 probability आ चुकी है, जो कि हमने cumulative Z table से find किया है. As this value of 0.0352 is less than 0.05, that is our alpha value, जिसको हम observed p-value भी कहते हैं. That means our value is falling in the rejection region. So we will reject H0 and conclude that the median endurance score of animals with electrodes implanted in the forebrain is less than 97.5.